Okay, dear colleagues, I'm very new in your community, and I am very grateful to Arnold for my invitation to this conference. We will speak about another non-linear property of laser-induced plasma. A topic is laser-induced plasma lasers, and mostly we will speak about these lasers' polarization effects. Shortly, what is laser-induced plasma? It is preliminarily created laser plasma was pumped by another laser tuned in resonance with optical transitions of atoms inside plasma. And as a result, we got intense, low divergent, some narrow and sometimes polarized radiation. And placing this plasma inside optical resonator, we increase this radiation intensity and decrease its divergence. We call this effect laser-induced plasma. It is really plasma, it is again generation effects. Okay. In our laboratory in Ariel University, we investigated many such lasers. It's lasers on elements from 13th group, 14th groups, and also these elements. On all these elements, we found this effect. In this, here you see the common properties of these lasers. What is interesting for my opinion, more interesting for my opinion, is that these lasers is intrinsically polarized. That is not common for other lasers. And we find that this polarization may be governed by relatively low magnetic field, external magnetic field. Here you see our experimental setup. Why it's not there? Oops. Okay. Here you see our experimental setup. Plasma is produced by this channel. Plasma plume extrapolated as a cylinder with 5 millimeter long and half millimeter diameter. Plasma is pumped by OPO laser, as I told you, in resonance with strong optical transition of elements inside plasma. Plasma is placed inside optical resonator, and this channel is plasma generation detection channel. Here we placed polarization analyzer. What is first of all, plasma parameters. We investigated many such elements, and plasma temperature at moment of pumping was varied from 5 up to 8,000 degree Kelvin. This depends on elements under investigation. And electron temperature, electron density in this plasma was at this moment about 10 power 16 years. Now, here in more details, you see our geometry is pumping geometry. It is transfer pumping geometry, pumping direction, generation direction, and pumping is vertically polarized. And this measure of polarization, we used degree of polarization obeyed by this equation, where that means that we measured generation components parallel with polarization parallel and normal to pumping polarization vector. Here you see our magnetic experiment geometry. Here, in this lecture, we will speak only about a special case of pumping and generation. Example is germanium laser-induced plasma lasers. Pumping occurs from the ground state multiplet to upper line level, and from this level directly open generation to intermediate empty levels. In laser physics, it is called quasi three-level generation scheme, but we nominate it as a direct generation because the generation occurs directly from pumped level. Another slide, you see that this laser, many lines of this laser pumping geometry is here, and magnetic field geometry is here. This column shows polarization of these lines generation in absence of magnetic field, and implying magnetic field in this direction that is collinear to generation direction. We strongly reduce this polarization or even change the sign of the degree of polarization from minus to plus or vice versa. These properties, how we explain these properties? Polarization and influence of external magnetic field is like to that for Hammer effects in, for example, in mercury atoms. It is classic first found Hammer effect. Okay. The essence of these effects is that resonant pumping and take into account Zeeman degenerated level of these transitions. Linear polarized excitation excite these two sigma transition, creating in degenerated magnetic excited states strong collinearity, and radiation from these degenerated states interfere and produce linearly polarized emission. And applying that we see in our experiments. And applying magnetic field, which reduce this degeneracy, reduce this coherence in these excited states, and reduce this polarization, degree of polarization. I return to previous. We found that in this generation scheme, the strong, very interesting peculiarity that is not found in other generation schemes. You see that we have here splitted ground level 3p1 and CP0 3p1 to upper line generation scheme. Two pumping this or this, and generation the same generation, but polarization in this case, blue case, is positive. In black case, it's negative. And this effect is found in many other lasers generating with this direct generation scheme. Example is, for example, the previous was germanium laser. This is example on vanadium laser-induced plasma lasers. The same scheme, changing starting level J on 1 leads to change the same generation, but its degree of polarization change from plus or minus. And another additional finding that if generation occurred to to lower generation multiplet, changing generation J on 1, delta J equal 1, leads to appearance polarized generation, but sign of generation will be plus or this. This is plus, this is minus. Another example, this one, pumping from the same level, but generation upper level, different J leads to different sign of generation level. This peculiarity we try to explain if we accept this Hanley explanation, Hanley effect explanation for laser-induced plasma laser generation, which we generate accordingly to direct generation scheme. For example, this transition, pumping from 1P0 to upper level leads to pumping these two sigma states, creating coherent states, and generation of these two transition, which produce by some reason we do not explain, we can't explain why it is positive, but leads to positive degree of polarization. Pumping from another this level leads to appearance additional sigma plus sigma minus transition, and maybe this is the reason why the degree of polarization for the same emission or the same generation will change this sign to minus. And also a high degree of polarization, but the sign is negative. So another interesting example that we found, and it's unequal for all other experiments, we found that copper laser-induced plasma lasers generation scheme is like to the previous. It is direct pumping scheme, pumping from this level to upper generation level. This one leads to appearance strong this generation and much weaker, but also this generation level. Pumping to this level leads to appearance these two generation lines. In the previous geometry, when magnetic field was collinear to generation direction, this generation not polarized in absence and in presence of magnetic field. In this geometry, when magnetic field is normal to generation direction, we found also that in absence of magnetic field is not polarized, but applying magnetic field leads to appearance of polarization. And we explained, it may be explained, or a hardware explanation maybe that we have deal here with crossing finally split excited states. Magnetic field, in this case, in absence of magnetic field, there is no degeneracy and therefore no polarization. Magnetic field leads to creation of degeneracy of this excited level and appearance of polarization. This Hanley effect explanation have a problem. The problem is that Hanley effect predict the degree of polarization may change from some value to 0. We found that in our experiments, the degree of polarization in magnetic field may change from some level to 0 and even change its sign. Here from plus to minus in the titanium laser-induced plasma. In vanadium laser, another example, the sign degree of polarization sign change from minus, strong polarization from minus to plus. And that is not predicted or not explained in direct Hanley effect explanation. And the same effect problem is for cup laser-induced plasma laser. This scheme predicts that independence degree of polarization on magnetic field here must be maximum in this dependence. But our experiments do not show this maximum. You see that in magnetic cup laser, degree of polarization also changed from, or appears 0 to -4 in this case, and from 0 to almost 1 in this case, but no any maximum power. So I finished my lecture, and here conclusion. It may be supposed that Henry effect is responsible for direct generation laser-induced plasma lasers, polarization and magnetic effects, but the theory must be extended to direct generation laser effects. Thank you for your attention.
Thank you. So we discussed with Lev yesterday about this collaboration. So I think that I will help with some explanations. So when I studied PhD, I worked with Mart Sauziņš, and his topic was similar with this about Clebsch-Gordan coefficients, about energy levels, rate equations, and so this is looks a bit simpler. So I try to help.
Thank you.
So are there some questions? Suna, please.
I have some similar comments. The whole effect reminds me on my PhD days, more than 50 years ago, when we did a lot with the whole effect. And I could also remind on that as a peculiarity, the whole effect is a good way to measure the magnetic fields of the sun by the depolarization and so on in the magnetic field. Another comment talking about laser-produced plasmas, we heard a lot from both here from Dr. Kim and from Rashid about laser-produced plasmas before. And of course, laser-produced plasmas are very good for many reasons and other reasons. For instance, to produce a laser-produced plasma, wait some time and then excite and measure the lifetime of ionic states and so on. So it's a strong competitor to the beam foil without the cascading effect. We did dozens of papers on that with astrophysicists. So that's a very good way. It's also pump-prone, exactly like this. The other aspect is, of course, LIPS that was discussed there, where you also make a delay and let it cool down, get rid of the electrons and so on. And in Lund, we worked a lot with remote LIPS, like on the Martian probes, actually, for the cliffs we heard about from Dr. Fowing here. The third aspect is, of course, to pump even harder and get the, from the plasma, the X-ray lasers, where you have very short wavelength emissions and population conversion.
Yes.
It's also a big field where there are lots of international conferences and so on. We also worked a bit in that area. I think this was very interesting aspect of plasmas and the whole effect. Thank you.
Thank you.
As a question came from Nagli, yes.
Keeping the sign of degree of polarization, is it corresponding to linear polarization or something?
Yes. We also all the time it's vertically polarized OPO laser, which pumps the plasma. And related to this vertical polarization, you have or negative or positive. That means in these experiments, maybe. In these experiments, degree of polarization is this one. In one case, this component is intensity much stronger than this. In the other case, this component is larger than this. This is yes.
Maybe according to this question, if it's linearly polarized, yes. So usually light inside a resonator is not always polarized, because the idea of a laser is what's going like this at the point, what's going like this is just.
It's a peculiarity of these lasers. We have no one of explanation is Henry effect, that we excite two sigma components and creating coherent excited state from which two generation interfere and produce starting spontaneous emission, polarized spontaneous emission for generation. It's one explanation. Some problem we have is also with this explanation. Maybe there is another one, but we know that most of lasers are not polarized, intrinsically not polarized. We must play inside the elements which polarize emission, and in this case we got polarized generation. But here we have intrinsically polarized generation.
Okay, thank you.